Hello students, welcome back to Chemistry Online class brought to you by IOTA Virtual Learning Platform. I am Olawoye Olabisi, your chemistry tutor. Here on this platform, we select topics from the WAEC syllabus and we back them up with past questions. So the topic we are treating today is chemical bonding. Chemical bonding is an important topic in chemistry because it has to do with the interaction between the outermost electrons of atoms to achieve a stable octet or duplet structure. It is the basis with which compounds are formed. So elements or atoms of elements combine together by gaining, losing, or sharing electrons, leading to the formation of either ionic bonding or covalent bonding. We also have other types of bonding as well. All this as a result of chemical bonding, that is, chemical combination of two or more atoms of different elements. And anytime element does this, they are trying to be stable or to attain the nearest octet or duplet structure. Looking at the structure of an atom, they have shells where electrons are found, and so this shell here is a valence shell, and electrons there are the valence electrons. It is this valence electron that participates in bonding with another atom of element, with the valence electron of another atom of element. Say for instance, now hydrogen has 1 as the atomic number, so it has just 1 electron. The first shell of every atom supposed to take 2, maximum of 2. The second shell supposed to take 8. So since hydrogen has atomic number of 1, it's in the first shell, is in need of 1 more to make it 2. So when it combines with another hydrogen or with other elements, it becomes 2. That's the nearest stable duplet structure. While fluorine, on the other hand, with atomic number of 9, has 2 on the first shell, 7 on the second shell, in need of 1 more to make it 8 outside to complete octet structure, to make a complete octet structure. So fluorine can combine with another fluorine or with other elements to make a stable octet structure. There are 2 categories of chemical bonding. We have the intermolecular forces of attraction. This one is between one molecule and another molecule. That's why we call it inter. Between a molecule of water and another molecule of water. The oxygen of water here, H2O, reacts with the hydrogen of another water molecule, resulting into intermolecular forces of attraction, that is, bonding between one molecule and another molecule. Examples of these are hydrogen bonding, metallic bonding, and van der Waals forces. We also have intramolecular forces of attraction. This is within a molecule, that is, if you're considering a molecule of water, between the hydrogen and oxygen of water, inside the molecule of water is intramolecular forces of attraction. Examples here are electrovalent bonding, which is also known as ionic bonding. We also have covalent bonding, classified as ordinary covalent bonding, and coordinate covalent bonding, which is also known as dative bonding. So we are considering the intermolecular forces first. We have just 3 here. The first one is a metallic bond. This metallic bond is found in iron, in metals, so to say. Example is iron. So in the atoms of metals, metals have free valence electron. Let's consider sodium, for instance. The atomic number of sodium is 11. Arranging it, we have the 2 on the first shell, 8 on the second shell, then 1 electron filled the last shell. So if we have 1 atom of sodium here, another atom of sodium here with 1 valence shell containing 1 free electrons, which will be given out. So each of these free electrons constitutes what we call mobile electrons, and they are negative. Electrons are negative. So when these free mobile electrons react with the positively charged ions or the nucleus of the metal itself, because whenever metal gives out, they become positively charged, there will be a kind of electrostatic attraction between the electrons and the positive nucleus of the atom, resulting into metallic bonding. So this is present in metals. Another one is hydrogen bonding. Hydrogen bonding is an intermolecular force which arises anytime hydrogen is covalently linked to a strongly electronegative element. In this case, now, example of electronegative elements that are very strong are nitrogen, oxygen, fluorine. Now, what happens is that between hydrogen and fluorine, for instance, a dipole will be formed. That is, hydrogen is positive, fluorine is negative. So we have 2-pole dipole will be formed, and then an electrostatic attraction will be created between the positive pole and negative pole, resulting to hydrogen bonding. Let's consider water, for instance. Now, if you draw the structure of water, you will notice that water, since this is intermolecular, this is a molecule of water, this is another molecule of water, hydrogen, 2 hydrogen and 1 oxygen. Now, between the hydrogen and oxygen of water here, there is what we call a broken line. This represents the hydrogen bonding between hydrogen of one molecule of water and the oxygen of another molecule of water, resulting into hydrogen bonding, because there will be a dipole formation here which is positive and a dipole formation here which is negative, resulting into hydrogen bonding. This is responsible for the high boiling point of water, and why water has high density, and is also responsible for the dimer formation, dimerization of hydrogen fluoride. We have H1, F1, H2, F2, and so on, because of this hydrogen bonding, which when forming clusters, they become strong. The last one here is the van der Waals forces of attraction. This exists in gases, especially weak gases, and substances that sublimes easily. A very good example of substance that sublime here is iodine and naphthalene. This bond, van der Waals force, is present also in noble gases, and is responsible for is important in the liquefaction of gases as well. That is, by changing gases to liquid. This bonding is responsible because when the bond is in such gas that is very weak, it will be easy to convert it to a liquid. And also substances like iodine and naphthalene that sublime, that is, they change from solid directly to gas without passing through the liquid state, meaning that they are held by weak bond for them to have changed from solid directly to gas. So this is also an example of intermolecular force called van der Waals force. All these are weak types of forces. They are not as strong as the intramolecular forces, which are ionic electrovalent bonding, for instance. In ionic electrovalent bonding, this is an example of intramolecular force, that is within a molecule of a compound. Within a molecule of a compound, all these compounds are examples of ionic bonding, and it involves complete transfer between an element, between the atom of a metallic element to a non-metallic atom, resulting in the formation of ions. That is, whenever elements have not given out their electrons, that is, the atom of an element has not given out its electron, they are called atoms. After giving out, they become ions. So whenever an element gives out its electron, because they are losing something negative, they become positively charged. And whenever an element receives, it becomes negatively charged because it's accepting something negative. So there is a complete transfer of electrons, just like I said, and ions will be formed. So that's why we call this ionic bonding or electrovalent bonding. Let's consider a very good example here between sodium and chlorine to form sodium chloride. The atomic number of sodium is 11. You need to know the first 20 elements to be able to get those elements that have positive charge and those that have negative charges. So chlorine is 17, meaning that they have atomic number of 17 and proton 17. Proton here is 11, electron is also 17 and 11 respectively. So representing them in the structure here, we have 2 on the first shell, which will be the maximum number of electrons, and then 8 here. Then the last shell takes 1, that's for sodium. Then for chlorine, we have 2, 8, 7. Now you can take note that, if you take note, you will notice that these electrons are arranged in pair. The last electron here is 7, so the valence electron of chlorine is 7. Are 7. So we have 2, 2, 2, 1. This is in need of 1 more. Why sodium here cannot gain 7 more to make it 8 here? Why this one needs 1 to make it 8? Sodium will give out completely. Using the Lewis dot structure, we can represent this. This dot here so shows the valence electron of sodium. Valence electron is the electron at the outermost shell. So why this shows the valence electron of chlorine, and this part is missing. So you can see them in pair, and then after sodium has given out, it becomes sodium ion with the number of charges it has given out. That's the number of electrons, and it's coming positively charged because it's giving out something negative. And then chlorine is becoming chloride ion with negative sign because it's accepting an electron that is negative and is -1. So that's why ions are formed, and then there will be an attraction between the positive and the negative charges, resulting into electrostatic attraction. Another example is calcium chloride. Here now, calcium atomic number is 20. We have 2 on the first shell, 8 on the second shell, 8 on the third shell, making it 18, and the last one is 2. This is a 2 valence electron, and this is the oxidation number and valence electron of calcium. Now, calcium needs 6 more to complete the shell, but cannot get 6, can rather give out 2 easily. Now, chlorine here has 17, so we have 2, 8, 7. Chlorine is in need of 1 here, but calcium is ready to give out 2. So it means 2 chlorine will combine with calcium, each transferring 1 electron, each accepting 1 electron to make them stable. So calcium becomes 18, while chlorine becomes 18 and 18 as well. So you can see the dot diagram here represent the valence electron of calcium, and this 7 represent the valence electron of each of the chlorine, with 1 missing each. So after giving out 2, it becomes Ca2 plus, because it's giving out 2 electrons, and the electrons are negative, so it's becoming positively charged. And most elements that gives out electrons are metals, and they become positively charged after giving out. They change from atom to ions. Now this one becomes negatively charged, -1, -1, and then you have calcium chloride, that is 1 calcium and 2 chlorine. What are the properties of ionic compound? You can see other examples of ionic compound: magnesium oxide, potassium chloride, magnesium chloride, calcium oxide, sodium oxide, and so on. Now we can see here that because ions are formed in a ionic compound, they are soluble in polar solvent like water. Water actually has 2 poles. We have the positive pole and the negative pole of water. So any substance that will be soluble in water must also have ions. So that's why most ionic compounds are soluble in polar solvents like water. That is, they have poles, positive and negative poles. So they are not soluble. These ionic compounds are not soluble in organic compound. They also conduct electricity in molten state. Why? Because when there's traces of water in them, they ionize easily to form ions, and they are good electrolytes. That is, they are used in the medium by which they are used as electrolytes that forms ions in electricity. And they also form crystal lattice because of the electrostatic attraction between the positive and the negative charges of their compound. We have the giant crystal of sodium chloride and calcium chloride, and then because of that, it requires high melting and boiling point to break them. This kind of bond is stronger than the covalent bond. So we are moving over to covalent bonding, which is also an example of intramolecular force of attraction, and it is divided into 2. We have the ordinary covalent bonding and then the dative bonding, which is also known as coordinate covalent bonding. Now in covalent bonding, there's a transfer of electron, there's sharing of electron. While in electrovalent bonding, which is also known as ionic bonding, there is complete transfer. But in this case now, covalent bonding, there's sharing of electrons. Now in dative bonding as well, we also have the bonding between a covalent molecule that is already formed and a proton. So I'm going to explain this later. Let's look at an example of covalent bonding. A very good example here of molecules that are formed by covalent bonding is carbon dioxide. In covalent bonding, molecules are formed like gases and liquid. So the bond is not as strong as ionic bonding. Carbon dioxide, carbon here is atomic number is 6, oxygen is 8. Arranging carbon, we have 2 on the first shell, and then carbon has 4 valence electrons on the last shell here, each in need of 1 electron, making them 6. So oxygen, on the other hand, has atomic number of 8. We have 2 on the first shell and 6 on the outermost shell, arranged as 2, 2, 1, 1, each in need of 1 electrons each. So what happens here is that 2 oxygen combine with 1 carbon. There is oxygen on this side too. Now, what happens is that there will be a kind of relationship here. Oxygen supplies the need of carbon here, while carbon also supplies the need of oxygen. The same thing happens here. So you can see sharing between this side, on this side. So there is a kind of establishment of a bond here and another bond here. The same thing happens here. This supplies the need of carbon, while this supplies the need of oxygen. The same thing happens here. So we also have another kind of bonding taking place in 2 different places on this side. So this is represented as Lewis dot diagram. You can see these dots representing the valence electron. These are the lone pair. They are complete. They are not participating in bonding here. While these ones need electrons. These are the valence electron of carbon, each in need of 1, 1, 1. So when bonding takes place between these, this is supplying the need of this, and this is also supplying the need of carbon. The same thing happens here. So you see bonding taking place between the carbon and oxygen to give you carbon dioxide. As you can see, the double bond here, because there are two different parts of bonding. So we have C at the center surrounded by 2 oxygen to give you CO2, carbon dioxide molecule. And another example is water. Water also is reaction is between oxygen and hydrogen. Oxygen has 6 valence electron because the atomic number is 8. We have 2 and 6. 2, 2, 1, 1 outside. These are the 2 lone pair. Then hydrogen, on the other hand, has atomic number of 1. So the first shell takes 1 electron, is in need of 1 more. Another hydrogen here surround oxygen, in need of 1 more. So how does this sharing take place? There is a transfer from oxygen to the hydrogen to this part that is missing hydrogen, and then this one on hydrogen also supply the need of oxygen. There is also sharing here, and then we have something like this. These are the dots diagram representing the structure, and then we have this kind of structure being formed because these are the valence electron of oxygen, that is electron on the outermost shell. 2 is inside. From the atomic number, we have 6 left. 2, 2, 1, 1. Each in need of 1 electron is. While hydrogen also has 1 in need of 1. So this one of hydrogen supplies the need of oxygen. While this one of oxygen supplies the need of hydrogen. The same thing happens here, and then we have water. Other examples are oxygen. Here in oxygen, you can see reaction between oxygen and another oxygen. Now they undergo sharing side by side. And then we have the dot diagram of oxygen because atomic number is 8. We have 2 inside and 6 outside. 2, 2, 1, 1. Each in need of 1, 1 left. The same thing happens here, and then bonding takes place. This one supply the need of oxygen here. This also supply the need of oxygen. This represents electrons. These dots represent electrons. This supply the need of oxygen. The same thing happens here, and then we have double bonding to form oxygen molecule. The last example is ethene. In ethene, that's an organic compound between 2 carbon and 4 hydrogen. We have 1 carbon here. The atomic number is 6, so we have 2 and 4. Each in need of 1, 1, 1 electrons each to make them 8. The same carbon also, another carbon also has the same problem here. So they are surrounded by 4 hydrogens. So how does bonding take place? On this side of carbon is in need of 2 electrons. This side of carbon also in need of 2 electrons. Sharing takes place between this carbon. This one is an electron, supplies the need of the carbon here. This supplies the need of the carbon here. This supply the need of this also supply the need of carbon here. On this side, we have hydrogen here. Is as one as the need of 1. It supplies the need of this carbon here. This also supply the need of hydrogen. The same thing takes place here, and then when sharing takes place like this, we have the dot diagram be represented here. Why these boxes represent the empty parts that needs to be filled. So sharing takes place between the electrons because 2 electrons are doing the work of 4. So when sharing takes place, this is between carbon and another carbon, and then this is carbon and hydrogen. So we have something like this because there are 2 different types of bonding at the center of carbon and another carbon. There are 2 points of bonding. We have 2 double bond here. Then we have 1 bond here, 1 bond here, 1 bond here, 1 bond here. So 1, 1 surrounded by 4 hydrogen to have C2H4. And so from there we move on to the factors affecting the formation of compounds from ions. What are the factors? The first one is ionization energy. The second one is electron affinity, and the third one is electronegativity difference. Ionization energy is actually the energy required to remove the valence electron of a gaseous atom to form a gaseous ion. This is usually lower in electropositive element compared to electronegative element. Why? Because most electropositive element gives out the electrons easily. Take for instance sodium. Atomic number is 11. We have 2, 8, and 1 on the last shell. This is a need of 7 more to make a complete shell, which is 8. So it cannot gain 7 it can give out one easily. So it requires less energy to remove the valence electron compared to chlorine 287, because chlorine has atomic number of 17. So we have 8 and 7 on the outermost shell in need of just 1. So chlorine will behave like an electronegative element because it is ready to accept electron that is negative to itself to make it balance, and it's take a greater energy to remove the valence electron, while that of sodium will be very low. So electron affinity is also the energy released whenever a gaseous atom gains an electron. It's associated with electronegative elements anyway. When an electronegative element gains electrons easily, they have high electron affinity. These are the factors that enhances the formation of compounds from ions. That is, the electronegative element, one element must have electron affinity. If not, there won't be acceptance of electron. Another one must have high ionization energy, that is ready to accept electron rather than giving out, because it requires a greater energy to remove its valence electron. While the other one, we have low ionization energy, willing to give out its electron. Then the last one is electronegativity difference. Yeah, there must be a difference in electronegativity. One must be positive, the other must be negative before electrons can form compounds, before compounds can be formed from ions or from elements. And in the case of covalent molecules, which involve sharing, this may not necessarily be acceptable. And that leads us to the last part here, which is the question part. I'm going to pause the video here. I want you to attempt these questions, after which we'll come back. You should also pause the video, attempt the questions, then we come back for the solution of the question. We'll solve it together. Welcome back to the past question aspect on chemical bonding. I believe you were able to solve the questions based on the theoretical knowledge you've had when you listen to the class. And if you did not pay attention to this, please go back to the theory, listen properly, and you'll find out that it's very easy to answer these questions. It's subtract from different years of past questions. The first question here is: noble gas molecules are held together by A, van der Waals forces, B, hydrogen bond, C, dative bond, D, covalent bond. WAEC 2013 number 17. Actually, global gas must contain weak bond because they themselves, the gases, are weak. So I told you here that van der Waals forces are responsible for the bonding in most gases. So the answer here is van der Waals forces. But make sure you read through your options before you choose the best answer. Covalent bonding is for sharing, dative bonding, and here gases are formed, actually liquid are formed, but for noble gases that does not react together, they are held together by van der Waals forces. Formation of a bond between hydrogen and a highly electronegative atom results in what? A, polarity, B, electrovalent bond, C, dipole, D, metallic bond. Actually, this is from WAEC 2023 number 6. I told you that in hydrogen bonding, bonding occurs between hydrogen and a strongly electronegative element, resulting into the formation of a dipole where hydrogen is positive and the electronegative element, like fluorine for instance, is negative, and then you have two poles being formed, which means two poles, dipole. So the best answer is C. The next question is: positive ions in a sea of electrons are found in what? A, covalent bond, B, metallic bond, C, dative bond, D, ionic bond. This is why 2023 number 35. Positive ions enclosed in a sea of electrons are found in metallic bonding. I told you that inside metals are positively charged. They have positive charged nucleus, and then they are surrounded by free mobile electrons, which are negative. So there's an electrostatic attraction between the electrons and the positive nucleus to form metallic bonding, and this kind of bond is found in metal. So the answer is B. What is number 4? What is a covalent compound? This is a compound formed by the sharing of electrons of different atoms of elements of atoms of the same element, resulting in the formation of molecules. State 2 factors that influence covalent bonding. I gave you 3: ionization energy, electron affinity, electronegativity differences as another factor that influences covalent bonding. And then the two electrons must have high electron affinity for themselves. Ionization energy too, they must have high ionization energy, so they result into bonding because none of the elements is ready to is ready to give out his electron. Then electronegativity differences. There should be no difference in electronegativity. The two should be able to accept electrons, thereby resulting into sharing of electrons. But in ionic bonding, there must be electronegativity difference, which results into one giving out and the other one accepting. So one is definitely positive, that is ready to lose its electron, while the other is negative. But in covalent bonding, there must be no electronegativity difference. So state the type of bond that exists in each of the following substances: magnesium oxide, ammonia, and iron. For iron, the kind of bonding in iron is a metallic bonding. For ammonia, that reminds me of dative bonding that I need to go over. I'll quickly explain that of magnesium oxide first. There is a bonding between magnesium. Magnesium has atomic number of 12. So arranging it, we have 2, 8, that's 2, 2, 2, 2. And the last shell takes 2. Then oxygen has 2. Atomic number of oxygen is 8, 2, and 6. Arranged as 2, 2, 1, 1. So you can see here that oxygen needs 2 electrons more to form a stable octet, while magnesium cannot gain 6 to form a stable octet. So magnesium completely transfers electron to oxygen. So there is a complete transfer of electron to oxygen, making it stable. And this is what? Ionic bond, resulting into magnesium ions with 2 plus. And then oxide ion 2 minus, because it's accepting. This is given out. Ionic bonding is responsible for the formation of magnesium oxide. For ammonia, this is bonding between nitrogen. Nitrogen has atomic number of 7. So nitrogen here is 2, and then 5 outside, which is arranged as 2, then 1 in need of 1 electron, 1 in need of 1 electron, another 1 in need of 1 electron. So hydrogen, on the other hand, has 1 electron, is in need of 1 more. So 3 hydrogen here surrounds nitrogen, each in need of 1 electron. So the one of hydrogen here supply the need of nitrogen here. This also supply the need of hydrogen. The same thing takes place here. Bonding and sharing, bonding by sharing to give you ammonia. While for iron is metallic bonding between the free valence electron of iron, which is +2, and the nucleus, which is positive. Define covalent bonding. Covalent bonding is a kind of bonding that involves sharing of electrons that is formed but when elements share their electrons with themselves to attain a stable octet or duplex structure. Give 2 properties of covalent compound. Most covalent compound they have the opposite property of ionic compound. They are soluble in non-polar solvent like organic compound. They are weak. Molecules are formed in them, so they have low melting and boiling points in them, unlike ionic compound. And the core property of dative compound is also similar to covalent compound because they both involve covalence, that's sharing of electrons. Only the dative molecules are much more volatile than covalent compound. That is, they escape, they form gases easily, they dry up easily. That's meaning of volatility. Now, with the aid of a diagram, show how ammonia molecule is formed. I've just explained that here. That's another year, WAEC 2018. This is intermolecular force. Here, there's a question here that has been omitted. This is WAEC 2011. What are intermolecular force? Intermolecular forces are forces that occur. That's number 4 Roman figure 4. They are the kind of bonding, but it's actually May June 2D, number 2D, May June 2011. Intermolecular forces are forces that occur between one molecule and another molecule, like a molecule of water reacting with another molecule of water between the oxygen and nitrogen of different molecules. That's intermolecular forces. Why I define intra as the kind of bonding alcohol or force that exists in a molecule, within a molecule. So with the aid of a diagram, show how ammonia molecule is formed. That has been explained here. Then the second to the last question here, illustrate with a diagram the formation of ammonium ion. Now, let me go back to the way nitrogen is being formed here. Sorry, the way ammonia is being formed here, which is covalent because it involves sharing between nitrogen with 2. The atomic number of nitrogen is 7. So we have 2 here and 5 outside here. 2, 1, 1, 1. Each surrounded by hydrogen that has 1 as well, in need of 1 more, want to make a stable duplex structure. So there is a kind of sharing. Hydrogen supplies the need of the empty nitrogen here, empty space in nitrogen, while the only one of nitrogen also supply the need of hydrogen. The same thing takes place in 3 different spots to give you N, H, H, H. That's ammonia. But if you take notes, you will notice that there are 2 electrons here that are not participating in bonding. We call it lone pair. Now, oxidative bonding occurs when you have a covalent molecule combining with a proton. A proton is positive and is an empty hydrogen because elements become positive after they've given out the electron. So if hydrogen has only 1 electron and is now positive, it means that's giving out the only electron it has. So it comes around and claims the 2 lone pair on top of hydrogen here. Ordinarily, if you draw the structure of nitrogen, we have 2 and 5, making it 7. So you can see there are 2 electrons here that are not participating in bonding apart from these 3. So this lone pair is taken over by hydrogen bonding to form coordinate covalent bonding. That is the reaction between ammonia and hydrogen ion to give you ammonium ion. That is dative. Another example is between water and hydrogen ion to give you hydroxonium ion. This is covalent. When it now reacts with an empty hydrogen, it forms hydroxonium ion. That has answered this question, the formation of ammonium ion, and this is dative bonding. What type of bond exists in ammonia? That is sharing of electron, that is covalent. What of ammonium ion? Dative or coordinate covalent bonding. This is WAEC 2008. I want to encourage you to get more questions on this topic, search more past questions, and be patient when you are treating this question. Go back to the theoretical aspect if you are having issue, and then apply it in answering most of the questions that you come across under this. I must appreciate your effort for paying attention and for your patience till the end of the class. And I want you to watch out for the next part of this video, which is on IPAC nomenclature of simple ionic compound. God bless you. Thank you very much.